Hi, this is Ron Cipcic. In this particular video, we're going to take a look at the relationship between total revenue, marginal revenue, and the elasticity coefficient. And in understanding monopoly, it's very important that you understand these concepts because you'll understand some key ideas about how the monopolist behaves. Notice over here on the right side that we have a table. This table basically shows in data form the demand curve. So as the price drops by 1, sales increase by 1, 100, 1,000, 1 million, whatever the amount might be. Total revenue is price times quantity. So we see here that if we multiply the price times the quantity, we get 0, 8, 14, 18, 20. So between 9 and 5 we see total revenue increasing at a decreasing rate, hitting a maximum at 20, remaining at 20 between 4 and 5, 5 and 4, and then total revenue beginning to decrease at an increasing rate. And I don't continue the table all the way down, but you can see that total revenue is parabolic. In other words, it increases at a decreasing rate, hits a maximum at 20, and then begins to decrease at an increasing rate. Now, marginal revenue is the relationship, actually looks at the relationship between the change in total revenue and the change in Q. So as we increase Q from 0 to 1, revenue increases by 8. And notice I'm going to put this between the levels since marginal revenue is a change in the level, not the level. We go from 1 unit to 2 units, our revenue increases by 6. So that's the marginal revenue. We go from 2 to 3, our revenue increases by 4, and so on. So you can see that marginal revenue is decreasing. It's positive but decreasing until we get to a price of 5. Marginal revenue becomes 0. Yes, it's possible to produce a unit, the 5th unit. Our revenue does not increase between the 4th unit and the 5th unit, so our marginal revenue is 0. And then, of course, as we continue on, our revenue actually begins to decrease, and so our marginal revenue is negative. So we go from unit 5 to 6, our total revenue drops by 2. We go from 6 to 7, our total revenue drops by 4. Our marginal revenue has become negative. Yes, it's actually possible to produce a unit and see your revenue decrease. And if we continued further, we'd see that marginal revenue continues to decrease at a rate of 2. Notice over here on the right side, we've diagrammed the demand curve and the MR curve. And what we see is, we see that the MR curve is steeper than the demand curve. The table reflects that. Notice price is dropping at a rate of 1, whereas marginal revenue is dropping at a rate of 2. So we can see that the slope of the marginal revenue curve is actually -2 in this case, where the slope of the demand curve is -1. So the demand curve is actually flatter, although it's steep, it's flatter than the MR curve, which is actually steeper. Okay? Now, that's interesting, but it gets even more interesting because now we're going to connect the elasticity coefficient to marginal revenue and total revenue. If you remember from one of our earlier videos, in fact, I actually have done 2 videos on elasticity. In the first video, we learn how to calculate elasticity, and then I go on further to interpret it in the second video. But we see that the price elasticity of demand coefficient is the percentage change in the quantity demanded divided by the percentage change in price, absolute value of that number. And we operationalize that by using a midpoint formula over here to the right. And I'm not going to spend any time in this video going through this calculation. I assume that my viewer understands the ED calculation. And if you don't understand the ED calculation, you should go back and look at one of my earlier videos on the elasticity coefficient, the calculation of the elasticity coefficient. So I'm just going to go ahead and plug these numbers in here. This number is going to be 17, which is very, very high. The buyers are very, very price sensitive between a price change of 9 and 8. It's going to drop to 5 here. It's going to drop to 2.6 here. It'll drop to 1.57 here. And as we said in our earlier videos and earlier presentations, the ED coefficient decreases as you move down the demand curve. So there's a segment of the demand curve where the ED coefficient is actually greater than 1. And there is actually a segment of the demand curve where the ED coefficient is equal to 1. So we'll go ahead and note that. And if you keep going here, you'll see these ED coefficients become negative, 0.64, 0.38, and if we kept going, they would even become, I shouldn't say negative, they become less than 1. So we've got a segment here between 9 and 5 where the EDs are greater than 1. We have a segment between 5 and 4 where the EDs equal 1. And then anywhere between 4 and 0, the EDs are less than 1. And that's a very important principle here. Now let's just take a moment and think about this. You can be very mechanical here and you can memorize the rule, but we want to understand the rule too. So you can see here anywhere where MR is positive, ED is greater than 1. Anywhere where the MR is 0, the ED equals 1. And anywhere where MR is negative, ED is less than 1. Remember, ED is an absolute value, so an absolute value always has a positive value, which means the lowest the ED could ever be would be 0. So the EDs have to be somewhere above 0, but the dividing line on elasticity is 1. So greater than 1, elastic, buyers are price sensitive, less than 1, but a greater than 0, inelastic, and 1 is the dividing line, which often is called unit elasticity. Now notice, let's just kind of do the connection. So I'm going to, in words, explain this connection. So when we cut our price, say from 8 to 7, let's just look at this interval here. That's a 12.5% decrease in price if you actually check it out. However, sales have increased 100%. We've gone from 1 to 2 or 1,000 to 2,000, whatever. So relatively small drop in price, 12.5%. 8 to 7 is 12.5%. But 1 to 2 is 100% increase in Q. So the change in Q is very, very large compared to the change in price. Revenues increase, not only increase dramatically. If these were millions, 8 million to 14 million. If these were billions, 8 billion to 14 billion. I mean, that's an enormous increase in total revenue. Total revenue almost doubles. So marginal revenue is going to be positive. So look, we cut our price, we're taking less per unit, but we sell so many more units, our revenue increases. Well, our MR has to be positive. It goes up. So if total revenue is increasing, MR has to be positive, but that correlates with a very positive, a very large ED. The ED is 5 times greater than 1, which means the buyers are extremely price sensitive. Extremely price sensitive. Now go down here. Let's go between 3 and 2. 3 and 2 is an interesting price interval. If our price is cut from 3 to 2, that's a 33% decrease in price. That's a large decrease in price. But notice that our sales only increased 17% here, from 6 to 7. So if you actually take the percentage change from 3 to 2, that's 33% decrease, which is effectively double the percentage change in Q. The percentage change in Q is only a 16 or 17% increase. So notice that the price change is much larger than the Q change. So we've raised our price, or cut our price quite a bit, 33%, but our sales have only increased 16%. Our buyers are relatively price insensitive, as evidenced by the fact that our ED is less than 1. But notice, because we cut our price a lot and we don't sell that much more, our revenues decrease. Well, if our revenues are decreasing when we produce this last unit, our marginal revenue must be negative. So you can see that it's because of this insensitivity that revenues drop, and when revenues drop, MR has to be negative. Okay? So we can bring this information over to the diagram, and we see that where MR is 0, I'll just put that over here, where MR is 0, the ED must be 1. And we see that in our table. Where MR is 0, the ED must be 1, right? That's also where we maximize our total revenues. So where MR is 0, we maximize total revenue. Okay? And that's the key idea. This is the point where we maximize revenues. Notice that anywhere where MR is positive, over here, these are all positive values for MR, the ED has to be what? The ED has to be greater than 1. Anywhere where MR is negative, which would be down here, notice this is the negative quadrant, we're below 0. This is dollars here. So if we're below 0, it's negative. Well, what's true then? If MR is negative, ED has to be what? We have to be on a segment of the demand curve where what? ED is less than 1. Now we know from an earlier lesson that as we go down the demand curve, the ED gets smaller. But there's a relationship, what I'm trying to drive at is there's a relationship between the MR curve and the demand curve, we know that, and the EDs along that demand curve. All right? So that's important. That's one of the first things we want to pull. In fact, one of the most important things we want to pull from this lesson. Now, what I'm going to do is I'm going to put an MC curve in here, and I'll just use this elliptic function to do this, and I'll just use this color here to put my MC curve in, and I'll get rid of that guy so he doesn't get in our way. So this is the MC curve. Okay, the red line here is the MC curve. And let me use my little ruler function here. I just love to use my gadgets. This is kind of fun. And you know, when you've done this work for 32 years, you got to get joy out of the little things. So getting to play with the tools is fun. And we'll just run a dotted line down through that point where MC equals MR. Why? Because where MC equals MR, we know the firm maximizes profits. And then, of course, that's going to give us the optimal quantity down here, and it'll give us the optimal price up here. So we're going to pivot this ruler function. Isn't that cool? Almost makes you want to be an econ teacher and get to use the tools. So we'll use that. We're going to get rid of that. So where MC equals MR, we have what? We have profit maximization. So let me get rid of, this allows me to use my erasing function. There we go. That's cool. So back to our pen. So PM is not the maximum price, that's the profit maximizing price. Of course there are prices above this level, but PM is the profit maximizing price. Why? Because this is where MC equals MR. You go, I don't understand that. Well, then you need to go back to the past video where the last video, graph Monopoly, where I talk about profit maximization. And then where MC equals MR, we have Q max. And again, that's not the maximum quantity, it's the profit maximizing quantity. So we see, here's the point I'm driving at. The monopoly is never going to operate over here where MR equals 0 or where MR is negative, unless it's ignorant of the optimization point, which is possible. Firms in real life don't see these curves, and they don't have the kind of information we're supposing that they have. But the firm has no incentive to operate over here where it's producing units where MR is 0 or negative. Okay, so if MC is positive, and you would expect it to, it has to intersect mathematically with MR where it's positive. Okay, and therefore you're going to be over in this MR is positive area. That's the point I'm driving at, and that has interesting implications. Now let's just horse around with this a little bit and talk about this. So say the firm is operating somewhere over here, which means it's operating on the demand curve way up here. It's on the demand curve way up here, which means the price is way up here. Okay? If that firm wants to maximize profits, what does it have to do? It has to lower its price. Okay? It has to come down this demand curve, So as it lowers its price, it's going to move closer to QM. As it approaches QM and approaches PM, what's happening? Its profits, now listen carefully, its profits are increasing, but increasing at a decreasing rate. Remember, the profit function, if you go back and look at the earlier material, the profit function is parabolic. Profit increases at a decreasing rate. Increases at a decreasing rate. That's important. Increases at a decreasing rate. So that's good, it's why we're lowering the price. But notice also, as we move to the right, we're moving closer to the point where MR equals 0, which means total revenue is increasing at a decreasing rate. So if you're lowering the price, and we have the data over here, if you're lowering the price where ED is what? ED is greater than 1, total revenue is increasing at a decreasing rate. All right? So you should know that. You should know that if you're underproducing, if you're operating somewhere where MR is greater than MC, by lowering your price and raising your output rate, you can increase both your profit and your revenue. Now, let me change this around. Suppose that you're overproducing. You're somewhere over here, which means you're somewhere on the demand curve over here, which means you're operating somewhere down here. You're overproducing and underpricing. Well, as a monopoly, you have no incentive to overproduce and underprice. You're the only firm. You control the price. So if you have this information, you would want to what? You'd want to raise the price and reduce the output rate. As you raise the price and reduce the output rate, you're going to move closer to Qmax and Pmax, which means what? Your profit is going to increase at a decreasing rate. I mean, after all, if where MC equals MR is the maximum, not being there means you're not maximizing. So as you move closer to maximum, your profits are increasing, but in this case they're increasing at a decreasing rate. Notice though, this is what's interesting, you're actually moving away from the point where MR equals 0. If you're moving away from the point where MR equals 0, if you're raising your price and you're moving away from the point where here's MR equals 0, here's the total revenue where MR equals 0. If you're moving away from that, your total revenue is what? Decreasing at an increasing rate. So the paradox is, if you're moving from this overproduction point here where I have a blue X, and you're moving your output rate down, your profit is increasing at a decreasing rate, but your revenue is decreasing at an increasing rate. All right, and anybody who's watching a video like this has signed up for economics boot camp, and you say, oh, I'm confused. Well, I suggest that you watch the video again. Okay, and watch the video again until these concepts get, until they soak into your dry ground, until you get wet with this. But these are difficult ideas, and that's why we actually talk about them, and that's why we actually do videos on them, because they're not easy concepts. They're not easy to read about, and you have to review them a number of times to really get them in your head. So again, understanding the connection between TR, MR, and ED helps us understand some things about how the monopoly behaves. And I think we'll stop here because your eyes are probably already spinning and your head is probably already hurting. So let me give you a break. Okay, thanks for watching.